Hello everyone. Let's do more examples of integrals using by parts. So our next example here is we want to integrate x4 times ln of x dx. This is not a basic integral. We have the product of two terms. If you try a substitution, if you try to use u equal x4 or u equal ln of x, none of those substitutions are going to help you out. So let's try by parts. And let's use the approach that we use so far, which is using the power function or the polynomial function as the u and c. What happens if we do that? So suppose we have three terms. We have x4, ln of x and dx. So we want to use the by part method. So we have to choose what will be going inside u and what will go inside dv, knowing, of course, that dx is always paired with dv. So if we use the same approach that we used before, and we use x4 inside u and ln of x now inside dv, what's the problem with this choice? Well, of course, if you compute du, the derivative of x4 is 4x cubed dx, but then what is the integral? What is an antiderivative of ln of x? Well, that's not easy. So this is a common mistake, people putting ln of x inside dv, but you need to integrate ln of x. We know how to differentiate ln of x. We know the derivative of ln of x is 1 over x, but the antiderivative or a antiderivative of ln of x is a lot more complicated. So here, if you do this substitution, you are simply wrong. Okay, so this is bad. So we have to use something else in order to do this integral. So the only thing that we can permute here is the x4 and the ln of x. Simply put, as soon as you have an integral where you have to use by parts, ln of x will never go inside dv because you cannot integrate ln of x. So ln of x will always go inside u because the only thing you can do with ln of x is compute its derivative. So the true thing you have to do here is u equal to ln of x, and then dv will be x4 dx. So we still have everything. dx paired with the dv. x4 is with dv now, and ln of x is with u. So if we compute du, so if you compute the derivative of u, you get 1 over x dx. And now if you try to find a primitive for x4, well, x5 over 5 will do the trick. Again here, always make sure that your choices for u and dv contain everything. So we have all three terms, x4, ln of x, and dx. And now let's make sure that everything is well balanced using this circle of life. So here, ln of x, when you compute its derivative, you get 1 over x. And if you compute the derivative of x5 over 5, you get x4, because you get 5x4 over 5, and that simplifies to x4. So that looks like a correct computation and correct choices for u and dv and correct computations for du and v. So now if we apply this, so this integral will become uv. So ln of x times x5 over 5 minus the integral of everything freshly computed. So x5 over 5 times 1 over x dx. So here you just have to be careful. Don't be tempted to integrate too soon. You need to simplify if needed. So x5 over x will simplify to x4. So this, if I rearrange using the conventional order, so I'll put the power function first. So here x5 over 5 ln of x minus the integral of x4 over 5 dx. And now look at this. Even if our integral started with something complicated, we had like an expression that was a polynomial or a power function of degree 4 times a logarithmic function. And now we only have a degree 4, a basic integral to do. So now this will become x5 over 5 ln of x. The integral of x4, or a primitive for x4, will be x5 over 5 So that over 5 will multiply that other 5, so it will become over 25. And now that you're done, you just go plus C, and then you have your answer. So simply put, if you have an integral by parts and there's a logarithmic term involved, you have no choice. That logarithmic term will go inside you, not to be creepy or anything. All right, that's it for that example. Let's move on to the next example. So, of course, the next example is so beautiful. We know how to differentiate ln, but what is the indefinite integral of ln of x? So here we know it's not a basic integral, so don't be fooled. So there's always a good chunk of you, if you're asked to compute the integral of ln of x, who will reply, oh, it's 1 over x plus c. And those who do so, you deserve nothing in life. Okay, so it's not 1 over x. The derivative of ln of x is 1 over x, but not an antiderivative or ln of x. So it's not a basic integral. It looks basic, but it's not. And of course, we're within this section of integration by parts. So we're going to do this by parts. So here we have two terms only. We have ln of x and dx. And we know we cannot integrate ln. So if you are using by parts, so if you have u and dv, and we know the only place for dx is with dv, so we know dx is paired with dv, and then ln of x, we cannot put ln of x inside dv. The only place for ln of x is inside u. Okay, so here, ln of x, because the only thing you can do with ln of x, it's compute its derivative. So when you are computing du, you're going to get 1 over x dx. And when you're computing a primitive for 1, because dx is 1 dx, you're going to get x. And again here, always make sure that you take the time to make sure that this thing is well balanced. So here I like to draw my circle of life. So here the derivative of x is indeed 1 over x. So here I see it with my circle of life. And the derivative of x is indeed 1. So I know that this thing is well balanced. So now I apply my formula, so which is uv. So you're going to get, and again, uv is ln of x times x, but I like to write the x first. So it's x ln of x minus the integral of v du, which is x times 1 over x dx. And of course, very important here, this simplifies nicely. So here, x ln x stays the same. And x times 1 over x, that simplifies to 1. So you simply have to integrate 1 dx, and the integral of 1 is x, or 1 primitive for 1 is x. So you get x ln x minus x plus c. And if you remember, at the beginning of this chapter, we had to verify that x ln x minus x was an example of a primitive for ln of x, and this is where this function was taken from, is why it was obtained by using an integration using by parts. So now we have it. So you can integrate ln of x, but you have to use by parts. All right, for that example, for that beautiful example, that's it. All right, let's summarize these two examples with a remark. So if you start with an integral of the form x to some power times ln of x. Actually, ln of x could be ln of mx. If there's a coefficient in front of x, it's the same trick. But here, just a small remark here, k cannot be equal to minus 1, because if k is minus 1, you have a ln of x over x, and this integral can be done by substitution. So if you have a power of x times ln of x, then always, 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 you will put ln of x inside u, because you can only differentiate ln of x. And then dv will be the power of x dx. And to finish this question, you will apply the formula. So you will apply by parts only once. Okay, so you only need to apply by part once. If you look at the first example of this video, we had x to the power 4 times ln of x, and we only applied it once to finish this question. So it's absolutely efficient. So if you have a power of x other than -1 times ln of x, this question can be done using by parts, by making sure that you put ln of x inside u, and the rest, so the power of x, so xk, and the dx inside dv, and then you compute du, you compute v, you apply the formula once, simplify, and in one shot, you will get the final answer. So it's really, really beautiful. All right, so for this video, that's it. That's all. Bye-bye.